Okay, our next speaker is Pete Bennett from the University of Bristol, and he is going to give a short paper on Resonant Bits.
Okay. Hi, so I'm Pete Bennett, and I'm from the Interaction and Graphics group at the University of Bristol. And in this paper, I'm going to be proposing an interaction technique called Resonant Bits, where we're exploring the possibility of making digital information something you can resonate with. But first of all, I'll start by showing you a quick video of what this looks like. This just gives you an idea of what I'm talking about in the rest of the paper. So here we have a phone with a number of virtual pendulums. These pendulums you can resonate with just by merely rocking the phone, and you can pick out a single pendulum. So this is our basic sort of Resonant Bits technique, so jumping straight to it. And it's important to say at this point that the aim is to have it as a technique for all tangible interaction generally, and not just iPhones. So this is important to point out, it's an interaction technique, not an actual device. So how did we get to this? So I'll give you a quick background on how we got to this idea of resonant interaction. So it actually came from doing a project with a couple of magicians last year, and looking at technology for magic. And one of the magicians was particularly interested in Ouija boards and how Ouija boards move, and also in Victorian parlour games, such as using a pendulum. So this is something you can try yourself if you have a pendulum on you. An iPhone cable does work as well. Is if you hold a pendulum up in front of your face like this, and hold it dead still, so it's not moving, and then will it to move with the power of your mind, you might be surprised, because after about 30 seconds, it tends to follow your command. So if you want to move it away and towards you, it will, and then you can get clockwise and anti-clockwise going as well. Now, this is the Ideomotor response, which is a really interesting thing that happens where your body can actually provide the inputs to a system to provide an output, in this case the pendulum moving, where you can't actually feel you're doing it. So even when you know exactly what's happening, you still get a spooky interaction where the pendulum's moving. So this is what we wanted to harness, this kind of interaction. So now I'll give you the context. So that's the background on the technique. And the context we're doing this in, I brought my porcelain dog along. I'm working on a project called Tangible Memories across 3 care homes in Bristol. And we're looking at the specific task of putting stories into objects in care homes to aid memory and personal reminiscence. So this is the context I was designing this in. So really, brought the 2 things together, and really want to ask the question is, can you use resonance to get digital media out of a single object? So if there's multiple stories, maybe 100 stories in here, how can you resonate with the object to listen in and access that information without any extra buttons or augmented reality and so forth? So from that question, we designed a very basic iPhone app working with the pendulums, where the amplitude of the pendulum relates to the volume of the music. So if you have a kind of bit of slow space jazz, this is going on to a bit of sort of faster paced music, which is a slightly higher frequency pendulum. And then at the very end, you've got a bit of John Coltrane, sort of full speed pendulum. So this worked pretty well, and it engaged people, and we thought it had promise for using in the objects in care homes. So we've done a very brief pilot study to check whether, firstly, secondly, is this an interaction technique that works? Can people actually control this, or is it completely random? And then secondly, what are the design parameters? So the study we ran tested up to 15 pendulums on one device. I was wondering how many can you control at one time, and what kind of frequency range. So all the details in the paper, so I won't go into great depth on this, but I'll show you roughly what this looked like. So here you see the user is asked to resonate with the pendulum highlighted in the blue, and after a little bit of interaction, takes 3 or 4 seconds, they can resonate that, and it reaches a higher peak. So in this test, we're using this to provide data to work out how can you use this as an interaction technique. So you can use it for binary selection, where when it reaches a certain threshold, or do you look at the average energy put into a pendulum over amount of time, and when do you use this? Or do you use it as completely analog, where you just map the pendulum's movement to an output? So I recommend, look at the paper for the full details on that. I won't go into it, because I'm going to go on to the interaction possibilities. So this is I feel, the more interesting thing with this than the basic data. So what can you do with a resonant device? So firstly, one thing we're looking into is multi-device resonance. So if you have pendulums that resonate at a certain frequency, you can have multiple devices all connected to the same frequency, where you can actually help each other. So together you can rock the devices or move the stories to get more out than one person can alone. An interesting side effect is if you actually rock them alternatively, antagonistically, you can actually prevent someone from activating something. So that's quite an interesting sort of multi-device resonance. Another one that's we've been experimenting with is through surface interaction. Now this is where a tangible device normally you'd interact with by actually touching the tangible object. In this case, you can actually place it on a table, or a wobbly surface works better, and just by putting your hand on the table, you can cause enough movement to trigger the interaction. And this is a whole area, we haven't found any examples of this yet, so if anyone has any, please come tell me. But it's, interacting with an object through another surface. Taking this a bit further and removing the table, there's also the possibility of actually interacting through the air. So in this case, you wouldn't actually be able to transmit the real vibrations, so you'd have to use a connector or another motion tracking device to measure the movement of the hand. But we see this as a potential way for ubiquitous computing to interact with lots of devices at the same time. So if you have a different frequency for different devices around the room, you can sweep your hand, there's a ripple across all the devices in some way, maybe it's a sound, maybe it's light, and then you can hone in on one and interact with that particular device. Going on from there, there's also wobbly interfaces. So this is a particular area. At the moment, everything I've talked about has been input. So you've been inputting into a device. This is a potential form of resonant output. So this is where a device itself could have a curved base and actually resonate to display information from the computer and acts as a way to interact with that. So that's ongoing work. Now, coming full circle, back to the idea that inspired this, there's also the idea of idiomotor interaction. So what happens when, with a device, you can actually control it through micro movements. So far you've seen demonstrations where the device has been physically moving, and you can observe this. What happens with an iPhone when you use small motions that you can't actually see? So this is an unlock application we've been working on. It's just a screen grab, so you can have a play around this at the demo session. But this way, by concentrating one of the flashing bars, you can actually tune in and make it pop, as it were. And this is a really compelling interaction because it actually it's tuned so that it only works with micro movements. So if you shake it around, you can't pop them. It only works, and you see people get really, really engaged with this as they're honing in, trying to make it work. So I suggest coming along to have a look at that. So, in conclusion, I've just given a very brief overview of resonant bits as an interaction technique. So making digital information resonant, and then how can use that. In the paper, there's more details, but we've shown the viability as an actual interaction method. So in a very simple selection task, so it does work. People can actually select the one they want, and this was shown to be perfectly valid. And then just now, I've just gone through a few of the novel interaction methods this could bring about, and I'm happy to hear any more. So come and find me if there's any other ideas. And I think wrapping up about a minute early. Does anyone have any questions about this? Thank you.
Okay, let's give Pete a hand. Okay, any questions? Yep.
Hi, Pete. Stoffel from Umeå University. In the actual physical pendulum, of course, you have also the pendulum pulling back on you.
Yes.
Do you do something with that in this application, or have you looked into how the visual feedback maybe already is?
Yes. So So we have attempted ones that don't use visual feedback, so using audio feedback, and that works pretty well. And we would really like to look at haptic feedback, which is where the wobbly device is. So this is one where you can actually have the device wobbling, and that in itself provides the feedback and the input. So yes, that would be really good. Yeah.
Okay, and a question on the right side?
Hi, Jiffer Harriman, University of Colorado. This is reminding me of a piece that I got to take part in through this Stanford Laptop Orchestra a couple years ago, where we were actually swinging devices from their audio cables. And I'm wondering if you've considered different ways of achieving the resonance where you can actually feel the resonance in your hand, or other ways of getting feedback other than looking at the screen.
Yeah, so I almost answered that, I guess, in the last one. But yeah, we've looked at audio feedback and looking at haptic feedback. But as I say, this is early work in sort of interaction technique. So we're looking at more applications sort of as we go. But yeah, good, thank you.
It's a fun way to.
Yes, thanks.
Thank you. I think there's a Ouija board application in the making there.
Yes.
Everyone gave Pete a last hand.
Yeah.